Hi, everybody. Thanks for joining me on this fine October morning or afternoon or evening or whatever time it is where you are. I'm happy that you're here. So today we're going to be talking about cloud native observability with OpenTelemetry, which is a lot of words for some pretty exciting stuff that I'm really glad to share with you over the next hour here. So we're going to quickly talk about what we're going to be talking about. First, do a little introduction, tell you who I am. We're going to talk about OpenTelemetry sort of in a holistic fashion, right? As a top-down approach almost to orient you. Go through, some of the getting started stuff, show you how to actually implement this. And then finally, I've got a live demo of OpenTelemetry itself and a new OpenTelemetry demo application that you can get your hands on if you want to actually play around with some real code. So we'll be looking at that towards the end of our presentation. As mentioned, if you have questions, please put them in the chat. We'll have some time at the end to kind of go through Q&A. And with that said, let's get rolling. So first, to start off, I'm going to talk a little bit about who I am. And we're going to talk about a little bit about observability, which is a term that I assume a lot of us have heard, but maybe we still have some questions about, or we're not, 100%, there's a lot of people talking about observability out there, right? It's important to understand where we're coming from when we talk about it. So first, me. I'm a maintainer on the OpenTelemetry project. I've written a book called Distributed Tracing in Practice, which is all about distributed tracing, and I'm the head of developer relations over at Lightstep. So, if we're going to talk about observability and cloud native observability, we kind of need to talk about cloud native, right? And there was a very interesting statistic I found when I was researching for this presentation. And the Cloud Native Computing Foundation did a survey of cloud native companies, right? And this runs the gamut, right? This isn't just fancy Silicon Valley startups. This is large banks. This is places you've heard of. And of those organizations they surveyed, 96% of them are using Kubernetes. And I think that if you are using Kubernetes, you are building cloud native software. Just that's how it is. Kubernetes has gone from being maybe a somewhat obscure container orchestration method to effectively defining what it means to build a cloud native app in 2022, 2023. But when you start to build on Kubernetes and when you start to kind of move from traditional development architectures and traditional software architectures into cloud native, you get a lot of complexity that kind of comes for free. And it's complexity that isn't bad, right? It's good complexity. It's the kind of complexity that means you don't have to worry about what happens when my application crashes. Kubernetes will restart it. You don't have to worry about a lot of the things that, 10 years ago you would have had to get in Page to wake up for, right? You need to restart a server or a process, or you need to scale something out. Kubernetes does all that for you. But with all that good Kubernetes stuff, we have a lot of new problems about actually understanding performance because our performance profile has changed a lot with this. That's where observability comes in. Our systems have gotten very, very complex and complicated. We need something that help us model those systems and understand them in production, right? We don't have the luxury of being able to just go to the server that we know everything is running on and look at the logs anymore. We don't have the ability to necessarily hook a debugger up quite as easily as we used to. We need to be able to understand the state of our systems in production and get real-time information about what's going on, what's wrong, how can we improve the end user experience of using our software. So we need this not only for that end user experience I just talked about, but we also need it to kind of make better teams. They've done some, Google just came out, I think, with a 2022 State of DevOps report, right? And there's a lot of interesting takeaways in there, but one of them, the biggest one they saw, is that the biggest difference between teams that ship reliable software are teams that ship software quickly. Being able to reduce the cycle time of pushing a new change into production is one of the biggest indicators of reliable software, because it means that you are able to make changes with confidence. If you know that something breaks, oh, we can go fix it, right? Conversely, teams that ship slower on more like 3, 6, 8 month release cycles tended to have more defects. This is another benefit of observability. If you are going to be shipping quickly, then you need to know what's going on. Otherwise, how are you confident that you're making changes that aren't actually negatively impacting performance? this is even more of kind of a painful thing when you start thinking about modern teams, right? Obviously, some of us are still working from home, like me. Many people are going back to the office, but we've seen so many organizations, form over the past couple of years, and larger organizations sort of retool to a more hybrid or remote-friendly policy, where now instead of everyone being in the office and having your two pizza team and getting to sit and crowd around someone's monitor, you know, people can be on at different times of day. People are just geographically distributed. You need tools and practices that help you kind of bridge these gaps that maybe before you could have done by just going over and looking over someone's shoulder or asking someone a question. Now you need to be able to say, like, well, I need to understand this without actually having that person, by my side. I need to be able to do this programmatically, through tooling and through computer stuff, lack of a better word. To get observability, you need these three things, right? You need telemetry data, you need tools that can make use of that data, and then you need practices that help you operationalize that data. So today we're going to really focus on that first part, right? Telemetry data, specifically high quality telemetry data. And that is where OpenTelemetry comes in. OpenTelemetry is a project that is it's governed by the Cloud Native Computing Foundation, who are the people that help manage things like Kubernetes, Prometheus, Backstage, maybe other projects you've heard of. There's a whole range of open source projects under that umbrella. And the goal of OpenTelemetry is to enable effective observability by making high quality, portable telemetry data. We'll get on what that means about portable here in a minute, but the practical nature of this is OpenTelemetry is a collection of APIs, SDKs, and then tooling to help you create telemetry data and build observability pipelines. Now, one question I often get is, why did OpenTelemetry start with tracing? And there's a very good reason for that. It's so good of a reason I put it in big words here. Trace first observability. Tracing is a form of telemetry data that is really focused on sort of applications, and it's a form of contextual logging, right? A trace is really just a log from each of your services. Each of those individual logs per service is called a span, and they have a implicit context that is passed from service to service to service as a request moves through a distributed system. That context can then be applied to other OpenTelemetry signals like metrics and logs, thus unifying your telemetry together. Previously, maybe a really traditional kind of way of, doing like monitoring is maybe you have some metrics, right? Let's consider some sort of HTTP service, gRPC service, whatever. You'll go through and you'll create a metric histogram that shows you, like, okay, well, this is the number of 200s, this is the number of 300s, this is the number of 400s, this is the number of 500s, right? I have these buckets. And I know something's wrong because I see, that 500 bucket, the count of requests that are having a 500 response that's getting bigger and bigger and bigger. So I know there's a problem. Maybe I have an alert set on this, and so I get paged. It's like, okay, well, what next? Well, with just metrics and logs that don't have that context, my next step is usually to just try to figure out, like, okay, well, I know what service it's on, so let me go find where all those services are running, and then let me go in and start grepping through logs, right? Or looking in some sort of log search tool. Now, this is a way you can do things, but it doesn't give you a lot of context, right? And it also doesn't help you find like problems underneath problems. Maybe where those 500s are coming from, maybe that's sort of just the, place the problem is visible, but the actual cause of the problem, the actual thing that changed in your system is somewhere else that maybe you don't have great monitoring for, maybe you don't have great telemetry about. To fix this common issue, you need to have something that lets you see kind of at a service to service to service level, like what is actually happening in your system. So that's why tracing comes first, right? Tracing gives us that service to service context, and then it lets us link together all these other signal types so that we can very easily kind of move from one thing to the other. The other great thing about a trace is inherently sort of user facing. And but what I mean by that is you're tracing, end user requests, right? You're tracing what the person using your software is doing. because everything should start at, your edge or the client. And then you'll see like, oh, when someone tried to add a product to this cart, like this is actually what the experience was like for them. That means that traces are a great input to other monitoring primitives, right? So things like service level objectives. An SLO is a way to attach or to correlate business value with telemetry data. Since you're getting, since presumably the business value you care about is like customer satisfaction or something, having traces that are actually explicitly linked to that business value makes it really easy to create an SLO. You can also do things like heat maps and histograms, right? You can visualize performance as a shape rather than as a, number or a line. And you can also use traces to really easily build service graphs, which help you with that problem I was talking about of, not being able, maybe the place where I see the problem and the place where the problem actually occurred are different, right? So let's talk about how OpenTelemetry gets us there. One of the most powerful things about OpenTelemetry is the fact that it's a standards project, effectively. It's open source, it's completely free to use, it's under the Apache 2 license, and it's completely cloud native. So it's being built with things like Kubernetes in mind, right? It's being built from these modern systems. It also defines a lot of semantic conventions. A semantic convention is a standardized way to represent some metadata about a system. So perhaps you are, if you've tried to set up like multi-cloud before, host names can be different from cloud to cloud to cloud, right? There's not just host names, also like how's an IP address represented? How is a database server represented, right? So OpenTelemetry provides these conventions that make sure that regardless of your application runtime, regardless of your cloud, regardless of your container orchestrator, you're getting data that can be aggregated together on these conventional attributes regardless of the source. And that's very powerful because it means that we can build, not even just today, right, with existing sort of monitoring companies and observability companies, but you can think of a lot of things in the future, things like machine learning based tools that look at these semantic conventions and can know like, oh, this is a Kubernetes cluster, and I know because it has the standard metadata attached to it. The third thing is OTLP. Now, I mentioned earlier I would talk about portability. OTLP stands for OpenTelemetry Protocol, and it's a standard format for telemetry data exposition. By which I mean, rather than having to have, 2 or 3 or 10 different formats for the actual data you're sending to some sort of analysis engine, there's one now, and it's OTLP. This gives you, as an implementer, a lot of flexibility. If you are someone that operates software and you are, maybe you're an SRE, you have a lot more freedom now to say like, okay, well, we're going to start by building, completely open source. We're going to build our own open source platform. And it's going to take OTLP. Later down the line, maybe you decide, okay, I need to use some sort of commercial solution because the scale of my telemetry is too large. I can't run this myself. Without having to re-instrument anything, all you have to do is literally go into a config file and say, send the data over here now, and ta-da, your data is now flowing to a new destination. You didn't have to change any code. You didn't have to re-instrument anything. You didn't even have to import new libraries. You just change where that data is going. This is incredibly powerful and flexible for you as a operator. It's also very powerful for you if you are someone that is like providing frameworks or libraries, right? You can instrument your software with OpenTelemetry, and you can be guaranteed that someone else, that might want to integrate that later is going to be able to take that data and do something meaningful with it, irrespective of what monitoring platform they use, if they're using an open source or commercial solution, whatever. Finally, there's the W3C trace context. This is what actually powers that implicit context, that service context I was talking about earlier. And this is a W3C project, which is an actual standards body. But trace context is a way to make sure that, for every request, there's a unique ID that gets passed through all my services so that I can correlate all that information later. Because this is defined by the W3C, this means that, you shouldn't run into the situation in the future where some load balancer or some gateway starts dropping your tracing headers because it doesn't know about them, right? being standards-based means that we can ensure that everything kind of broadly accepts this. It also means that, we can go down the stack a little bit, right? Most of the time when I'm talking about this, I'm talking about application monitoring, but with these headers being part of the W3C, you could actually, go down the stack a little bit and imagine someday that this is actually applying to networking or other things that are aware of those headers. This results in consistent telemetry, consistent high-quality telemetry across your organization, across different platforms, across different clouds, across different languages, across, pretty much everything. And it's a great future to look forward to. Now, admittedly, we are on the way to that future. Things are pretty good right now, but, OpenTelemetry is a project started in 2019. So it's had tremendous growth within 3 years, but I do want to kind of point out that not everything is, 100%, right? There is a little bit of, if you were an early Kubernetes adopter, similar sort of experience. So how it actually works at a pretty high level is if you have this kind of architecture, right? There's two types of telemetry you're going to be dealing with. One of them is your transaction telemetry. So that is going to be traces and metrics and logs. And that's going to be created by using instrumentation agents or library instrumentation in your app code itself or in your frameworks. The other type is the resource telemetry. Resource telemetry is things from the cloud, right? It's logs, it's Kubernetes logs, it's Kubernetes metrics, it's stuff from CloudWatch, whatever, serverless logs. Those generally come in through special receivers that know how to translate that existing data into OpenTelemetry format. All that data goes into a set of OpenTelemetry collectors. OpenTelemetry collectors are telemetry, they're sort of a Swiss Army knife, if you think about it. They can take data in from a lot of places, they can modify it, they can filter it, they can process it, do whatever, and then they can translate it into some other format like OTLP, and then export it to open source tools like Jaeger, Prometheus, or there are over 15 vendors that support native OTLP ingest, including Lightstep. So that's the high-level architecture. That's kind of the intro. Let's talk a little bit about how you actually get started with this in your application. Excuse me. So to deploy OpenTelemetry, you kind of need two parts. You need the instrumentation. That's what actually gets you data out from your app into something else. And then you need to collect that data and export it. You can also think of this, if you've heard of an observability pipeline, that collection and export part is a part of an observability pipeline. Instrumenting itself can be done in several different ways. Generally, there's 3 different methods. One is to use automatic instrumentation agents. The agent is some process that kind of exists outside your app or wraps your application when you invoke it, and that is available in Java, C#, in beta, Node.js in beta, Python. Go actually has an alpha version of this where it will do the instrumentation through kind of an external process. These are the least intrusive because you don't actually have to modify your code, right? You just drop in the agent and go. But they're also, they're a good place to start, but you usually need to do a little more to get a lot of value out of the instrumentation. There's also extension-based instrumentation. So an extension is something that, extends a platform you're using. So if you're using like Lambda on AWS, there's an Lambda extension that will run kind of below, as a Lambda layer, I should say, sorry. It'll run as a Lambda layer, and that will automatically instrument your code and get traces out of it. There's a similar thing exists for Kubernetes, which I'll show you an example of here later. Finally, there's library-based. And library-based is something you're probably going to have to fall back on most of the time to get really good instrumentation out of your code. And you can use these in conjunction with each other. This isn't an either or. You can use the agent, if you're doing Java, you can install the Java agent, but then you can import the OpenTelemetry API as a library and extend that automatic instrumentation. I can show you an example of some of this here later. Installing the agents is going to vary by language, but it's usually fairly straightforward. For Java, for example, you download the latest release, you add it to the Java agent flag when you're invoking your jar, and there's some configuration you pass via environment variables. If you're using Kubernetes, there's a OpenTelemetry operator that will let you do quite a few things. It will let you stand up collectors to sort of collect telemetry. It will also let you add in these sort of instrumentation custom resources. So a instrumentation custom resource, it tells it, hey, here's what you export to, what propagator you want to use. It configures these options. And then you can annotate a pod and say, like, hey, inject the Java agent, inject the Node.js agent, inject the Python agent. So this is a very handy way for using Kubernetes, and you want to quickly get started with OpenTelemetry to do so. There's also, coming pretty soon, actually, we're going to have a Helm chart for doing OpenTelemetry or collecting all the metrics you need from your Kubernetes server using this operator. So check back around KubeCon time and we'll talk more about that. Either way, irrespective of how you actually instrument, you are going to want to do more than just install the agent or use an extension. You're going to want to add additional spans and attributes and events and other sorts of telemetry, and you're going to have to do that through the OpenTelemetry API. So there's a very exhaustive documentation about this per language, and in the demo, I'll actually kind of walk you through what it looks like to extend instrumentation through the OpenTelemetry API. But the details of this are going to vary based on the language you're using. The API itself is fairly consistent from language to language, but there are differences based on, obviously like C++ has slightly different syntax than Java. Either way, regardless of how you are instrumenting your code, the next thing you have to do is actually take that data and get it somewhere. So this is where the collector comes in. You can directly export from an SDK, so you can configure an agent to send data straight to Lightstep or wherever, but generally it's preferred to add a collector in the middle. And the reason why is that the collector lets you do things like, one, it lets you kind of receive a bunch of things other than just OTLP. So you can bring in resource data from if you're running on like an EC2 VM and you want to get instance metadata, well, you can install a collector and pull out the instance metadata and annotate all of your spans and metrics and things with that. You can also pull in Docker statistics. You can pull in database statistics, and metrics, whatever else. You can do a lot of processing. So there's filtering, like if you have like a health check that you want to drop, you don't want to see the spans in the health check. Well, you can drop that span using the filter processor. You can group and redact trace data. So if you have like PII, you want to make sure that, no credit card numbers or person identifying, personally unique identifiers get into your telemetry data. You can actually do that at the collector. The other thing that the collector can help you do is compress your data. So if you are exporting data from, to some monitoring service and you want to reduce your network egress costs, then the collector is really good for kind of batching stuff up, sampling it, and then compressing it so that you are spending less on, egress over the internet. And finally, you export to, again, OTLP, or there's 30 other exporter plugins. So everything from, sending stuff to Kafka, writing things to files, to various pub sub engines, to vendors that don't support OTLP. It's all there. Installing the collector is fairly straightforward. You download the latest release. One thing that gets people is that there are two distributions. There's one called Core and there's one called Contrib. Core is really the core distribution. It includes only things like OTLP. It doesn't include a lot of processors. It doesn't include a lot of extras. So if you're just playing around, then Contrib is a good place to get started. There's also a custom collector that you can build using the collector builder, and for a production deployment, that's generally what you would want to use. The collector builder lets you define a config file and then will build a binary that just has the stuff that you have defined in that config. So it reduces your surface area, it reduces the binary size. It's a good thing to do. All instances of the collector, regardless of how you build them, do need some configuration though. when you're configuring the collector, you're building what's called a pipeline, and the pipeline represents telemetry flowing into and through the collector. They always start with receivers, they may use processors, and then they always end at exporters. This is an example of a collector config. So conventionally, people will build their config with receivers, processors, exporters, and then extensions. Extensions I didn't talk about, but those are things that extend the functionality of the collector, like adding in a health check or adding in some sort of like debug endpoints. But generally you'll say receivers at the top, processors in the middle, exporters at the bottom. And every receiver has its own, YAML-based configuration. If you go into the actual GitHub repo for the collector and you go to the processor or receiver you're interested in, everything should have a README file that actually describes all the options. But in this case, we're setting one up that has OTLP receivers for both gRPC and then Proto over HTTP. We're also saying scrape the collector's own Prometheus metrics that it exports. We set up a batch processor. Batching will simply batch up telemetry. So instead of sending, every span has one outgoing request, it says we'll batch it up in every 5 seconds or every 50 megabytes, whatever. And this, again, better compression ratios and better, less bursty, more consistent network throughput. And finally, you configure an exporter. So there's a logging export, just writes to the console. There's also file exporters that write to files. There's also OTLP exporters, which I'll show you on the next slide. Once you've defined your receivers, processors, and exporters, then you go and build your pipelines. So these are defined under the service section. You can create as many pipelines as you want. If you want to split out your traces into 2 places, then you can create a trace receiver that has 2 different exporters, or the same data can go to 2 different exporters. If you want to do some filtering, you can have an include and exclude filter, and then make 2 different trace pipelines that send some of it here and some of it there. There's a lot of stuff you can do with this. It's fairly flexible. Sending to Lightstep, if you were gonna, you can go to sign up on Lightstep. If you go to Lightstep and sign up for a developer account, you can just send us data too. And because we accept OTLP natively, it's really just this little, this small amount of config is all you need to send data in. There's a few things that when you get the slides for this, we'll send the slides out later, that you can go through and read up on. But what I wanted to get to now, I talked a lot. I've been very patient with my talking. I'd actually like to show you OpenTelemetry and show you some code and show you what this kind of looks like in practice. So this is the OpenTelemetry demo application. And what the OpenTelemetry demo application is a microservice. It's a set of microservices running in Docker, or you can run it in Kubernetes as well. And it's is the project's idea of like, this is how you should do instrumentation. This is how you should like build OpenTelemetry into a system if you had the ability to kind of, go through and just psh. We're trying to be pretty exhaustive in our samples. So right now, you can see this is an alpha, although we do expect to have this be 1.0 in the next couple weeks before KubeCon. And what it will have is not just a bunch of services, but it'll have, you can see the languages here, right? So if you're a Java developer, that's something that you can go and look at. If you're .NET, Go, C++, PHP, Rust, we have actual implementation examples of OpenTelemetry in all these languages. And so you can go and look at this and figure out, and learn how you would implement this in your software today, right? So if we explore this a little bit, I want to kind of show you, walk through the code for one of these. Let's do the shipping service. Now this is in Rust, like we said. And you can see up here, this is actually one where there's no agent for Rust, right? You have to do the library instrumentation. You have to kind of like do all this bootstrapping yourself. But in general, this is how it works in any language. You pull in the API for tracing and metrics or logs. You pull in some global packages for the SDK that help tell things like, hey, this is how I want to propagate my context. And then you need some sort of exporter. In this case, we're getting OpenTelemetry OTLP. Usually you'll do some sort of conventionally, for like a smaller service, you'll want to kind of put all of your initialization stuff together. In this case, we have this init tracer function, and we set up a text map, a propagator, and that's what propagates that context. We create a pipeline to export it. In this case, I have this OTLP pipeline, and actually getting the where we want to send that telemetry data from an environment variable. You keep in mind this is some of this stuff again is not like the rest one is still, it's not 1.0 yet, so some features of the spec aren't implemented. So in this case, we're having to, we had to manually write the environment variable stuff here. But then we go to our main function, and generally you want to go and you want to initialize tracing and OpenTelemetry in general pretty close to application initialization. So in this case, we're setting up a health check and then, initialize logging and tracing pretty much immediately before we actually start up the server. And in that case, that's really all there is to this, I think, because there's this one, we have a quote service where we again are inputting the API, and we are going here. If you notice this span, right? Get active span. So this is asking the Rust tracing backend, which I think is called Tokyo, or that might be Erlang. Either way, we're asking the API to say like, hey, get the span for this request, and then we're able to take it and start doing stuff to it. So a span in OpenTelemetry has events, it has attributes. An event is you can think of it as a log message, right? Like when you write an event into the span, you're saying, here's sort of my human readable message, and then you can also add metadata to that. So in this case, we're adding this string is received quote, and then we're adding a attribute to it called app.shipping@cost.total. We can also set attributes. Attributes are things that you aggregate by, right? You can't aggregate spans by events. Events, they look like, I'll show you what they look like here shortly, but they're really more for the benefit of like you, the person going in and looking at the trace. Attributes, though, are things that you can kind of group your spans together by. And when you group them together by it, it lets you do cool things. Like you can start to ask questions about your application. Like, okay, in this case, we've got, app shipping.items.count. You're able to sort of make queries like, well, when app.shipping.items.count is over a certain amount, like what does the overall performance profile look like? Or when there is some issue kind of downstream or upstream of this service, is that correlated with this attribute? The other thing you're able to do with attributes in tools like Lightstep is kind of compare them across different signals. So Lightstep, we have this idea of unified observability, which lets us take metric and trace and log attributes and all that sort of stuff and let you compare them across each other using various features that I'll show you kind of here shortly. But it's really about taking those attributes and using those as the thing that you're using to kind of go from one thing to the other, right? OpenTelemetry, like I mentioned, will let you create exemplars. So an exemplar being, when I had this metric, I was reporting this metric, it's like, oh, there was a trace happening at the same time, so I can attach that trace ID to this metric measurement. And there are like some open source tools that will let you go and look at those exemplars. One thing we can do in Lightstep is we can really go beyond that. We can just say like, okay, well, for any combination of these attributes, we can kind of look at these different forms of these different signals and help you make inferences and jump from like one thing to the other in there. We'll have more to say about that here in a couple weeks, but it's something that, if you were looking at this and saying like, well, what's the difference between like any of these different backend services? That's the sort of thing that makes the difference. Previously, if you were someone that was trying to instrument software or you're trying to build a monitoring program or whatever, you had to make your decisions based off of what service has the dashboards I need, or what has the instrumentation I need for my software. With OpenTelemetry, you're able to kind of like step back and say like, okay, well, I know that all of the telemetry is going to be fine, so I can actually make decisions about where do I do the analysis based on features like that. So that's pretty neat. Let's look at another service. Like, let's see. Yeah, here's a Go service, for example. Go, also something where you have to kind of do a lot of this manual stuff, but again, we're doing the same patterns, right? You see how these patterns are repeating across languages. We have an initialization up at the top here, and then in our main we initialize our tracer. Let's look at something where we don't have that. So our add service here is Java. In this one, we are... Oh, we're not using the agent here, are we? Nope. But you can see some of what I was talking about, like set attribute is an API feature, and that's in every language. The actual like invocation is slightly different. In this case, it's set attribute. Some places it's set underscore attribute. Some of that consistency will come over time. Where's my static? So if we look at the Docker file here, oh, actually, yeah. So here's a good example of the agent. So if you look at the Docker file for this, we're actually downloading the OpenTelemetry Java agent, and then we're starting the Java agent with this jar. So if you notice in my Java code here, I do import some OpenTelemetry things, right? I'm getting API, I'm getting these extensions, these annotations. But I didn't actually have to go in here and do any of that configuration that we saw in the Go or the Rust service, right? That's because the agent is handling all that for me. So I can go in and I can know that, hey, there actually is a span here because the agent has handled all of the setting up OpenTelemetry in the background and injecting instrumentation into the gRPC server. So I can just get the current span and go from there. There's also these handy annotations in Java, like this with span. So this will create a span and automatically make it the child of whatever the other one was. And this is what I mean by kind of using a blend, right? We don't have to just use the agent. We actually do usually want to go in with some manual instrumentation in order to create these kind of app that adds that count, right? We want to create telemetry attributes that reflect business logic so that we can ask interesting questions about the data once we have it. So there's three ways of looking at this or of doing the instrumentation. The second thing, like I mentioned, we get the instrumentation, now we need the collection. So here's an example of a collector configuration. This is the default one for the demo, and it sets up metrics through Prometheus. It sets up Jaeger for tracing. But what we're doing is we're actually adding in this extra step here where we send it to Lightstep. And let's switch over and look at what that looks like in Lightstep. It's also, just to prove, like, this is the actual application, right? So OpenTelemetry, if you've noticed, is big on telescopes. So we have a telescope store. We also have this feature flag service. So I'm going to enable this feature flag in order to show you something interesting. So this is Lightstep. This is where I'm sending all that data. Again, it's also going to Jaeger and Prometheus, but in Lightstep we can look and we can see, this is sort of this is your top level view. This is your service directory. And this will show you for each endpoint, each API endpoint, you're able to go and look at things like the P50 latency, error rate, operation rate. And what's interesting is all this data you see here, this is actually derived from traces, not from metrics. So I'm not actually exporting metrics about, the latency on this endpoint. I'm just pulling the traces in, and Lightstep is analyzing those traces and giving me these, accurate P50, P90, P95s. I'm also able to go through and pop into, let's see here. Go into like the shipping service here. This is what we were looking at, the REST service we were looking at before. And I'm able to kind of explore this a little bit, right? So let me create a new notebook and look at demo exploration. So when I pop into this, I'm able to see my query builder. As I mentioned before, we're able to kind of effortlessly switch between metrics and traces here because Lightstep has a unified language and a unified query builder for these different types of telemetry. So if I wanted to kind of change this or add in a new chart here that was looking at, let's see, recommendations. This is the actual recommendation. This is the counter from the recommendation service about how many, the rate of recommendations per second, right? From these charts, I'm able to go and jump into a specific trace, and now I'm looking at the full end-to-end trace of one request from the front end all the way to the back end. And if we pop down to the shipping, shipping service. Here we are. So we see shipping service. Here's those log events I was talking about, right? These log events are really more just like things that are just human readable. And then if we want to actually, bounce back from there, it takes us to the old place. We don't want the old place. We can go and further refine this so we can look at other operations in the shipping service. So if we wanted to look at get quote, or if we wanted to look at ship order, or if we wanted to compare these, right? So right now I'm filtering, but if I wanted to group on that operation instead, we have the ability to do that and look at the difference between them. So this is really just a taste of what you can do in Lightstep, exploring this data, asking questions about it. If we had a little more time, I could go in and show you, looking at some errors in here and exploring other things. But you can do this yourself, right? If you go to github.com/open-telemetry/ OpenTelemetry-demo, you can get this for yourself, install it, play around with it with a free Lightstep account. That is all I have time for today.